Today we are going to discuss the topic Discrete Fourier Transform, derivation of Discrete Fourier Transform and inverse Discrete Fourier Transform we are going to study. So what is DFT? DFT means Discrete Fourier Transform. So this is the Fourier representation for finite duration sequence. X of n. We can convert a continuous time signal x of t into a discrete time signal x of n through sampling. That is, we can convert x of t into x of n by sampling with the t is equal to n into t, where small n is equal to 0, 1, 2, so on up to infinity. Next, we are going to derive the equation for Dft, derivation of Dft. Consider a finite duration sequence x of n consisting of capital L number of samples. Its Fourier representation is given by x of omega is equal to summation n is equal to 0 to L minus 1 x of n into e power minus j omega n. Call it as equation number 1. Then the frequency domain representation consists of replicas of x of omega which repeats with a period 2 pi. Let us take n equally spaced samples of x of omega in the interval 0 less than or equal to omega less than or equal to 2 pi. Then the samples are taken at frequencies omega k is equal to 2 pi by n into k, where k varies between 0 to n minus 1. Let us denote the samples x of omega k as x of k, and we have x of omega k is equal to x of k, which is equal to x of omega at omega is equal to omega k, or x of omega at omega is equal to omega k, we know 2 pi by n into k, where k varies between 0 to n minus 1. From equation number 1, we can write x of k is equal to summation n is equal to 0 to L minus 1 x of n e power minus j 2 pi by n into nk. Call it as equation number 2, where x of k is called n point Dft of x of n. Now we can replace L minus 1 by n minus 1 in equation number 2, that is by equating L is equal to n. Then equation number 2 becomes x of k is equal to summation n is equal to 0 to n minus 1 x of n e power minus j 2 pi n k by n, where k varies between 0 to n minus 1. I'm going to call it as equation number 3. So equation number 3 is called as analysis equation. It is called as analysis equation. So from the DFT samples, x of k we can synthesize the sequence x of n using inverse DFT or IDFT, which is given by x of n is equal to 1 by n summation k is equal to 0 to n minus 1 x of k into e power j 2 pi n k by n, where small n varies between 0 to n minus 1. Call it as equation number 4. Equation number 4 is called as synthesis equation. It is called as synthesis equation. Then x of n and x of k from DFT pair which is symbolically represented as x of n If we take Dft in point Dft, we get x of k, or if I take inverse of x of k, we get x of n. Now we are going to discuss some of the notations we are going to use while solving the problems. That is omega equal to e power minus j2 pi, which is known as Twiddle Factor, and omega suffix n, which is equal to e power minus j2 pi divided by n. This is Twiddle Factor for n number of samples. Omega n of nk e power minus j 2 pi n by n we know from the previous notation, and we have nk, and one more is omega n of nk star, which is equal to, so conjugate, hence it is e power j 2 pi nk by n. Now consider the analysis equation what we have discussed just now. X of k is equal to summation n is equal to 0 to n minus 1 x of n into e power minus j 2 pi nk by n, where k varies between 0 to n minus 1. Or using that notation I can write x of k is equal to summation n is equal to 0 to n minus 1 x of n. I am going to replace this term by omega n of nk, where k varies between 0 to n minus 1. This is the one equation, and consider the synthesis equation. X of n is equal to 1 by n summation k is equal to 0 to n minus 1 x of k e power j 2 pi nk by n, where n varies between 0 to n minus 1. Then x of n is equal to 1 by n summation k is equal to 0 to n minus 1 x of k into omega n of nk star, where n varies between 0 to n minus 1. So one more equation we have using the Twiddle factor. Next, some of the formulas we are going to discuss. First one, summation n is equal to 0 to infinity a power n is equal to 1 divided by 1 minus a, where mod a is less than 1. That means it is causal. Causal means a signal which starts from 0. And one more equation, summation n is equal to 0 to n minus 1 a to the power n is equal to 1 minus a to the power capital N divided by 1 minus a, with a not equal to 1. Then summation n is equal to 0 to n minus 1 of 1 is always n. We are going to solve one problem on this. Show that summation n is equal to 0 to n minus 1 e power minus j 2 pi nk by n is equal to n when k is equal to 0 and 0 when k not equal to 0. Solution for this: summation n is equal to 0 to n minus 1 e power minus j 2 pi nk by n. It is given in the problem, or we can write it as 1 minus e power minus j 2 pi nk by n to the power n divided by 1 minus e power minus j 2 pi k by n. So this is a to the power n. So this term is not there. We are going to write in terms of a to the power n. This is, we are going to consider it as a to the power n. So it is 1 minus a to the power capital N divided by 1 minus a, which is equal to 1 minus e power minus j 2 pi k divided by 1 minus e power minus j 2 pi k divided by capital N. But we know that e power minus j 2 pi k is equal to cos 2 pi k minus j sin 2 pi k, which is equal to 1 for k is equal to any integer value. Then summation n is equal to 0 to n minus 1 e power minus j 2 pi nk by n is equal to 0 for all k except k is equal to 0. Now consider summation n is equal to 0 to n minus 1 e power minus j 2 pi nk by n at k is equal to 0. At k, when we put k is equal to 0, we get e power minus j 2 pi n into 0 by n. That means e power 0 is 1. So summation becomes 0 to n minus 1 of 1. We know the formula, which is equal to n. Therefore, summation n is equal to 0 to n minus 1 e power minus j 2 pi nk by n is equal to n when k is equal to 0, 0 when k not equal to 0. Hence, prove. Next, we'll solve one problem on this. Find the 8-point DFT of the sequence x of n is equal to 1, 1, 1, 1, 0, 0, 0, 0. It is given n is equal to 8. So it is given the values x of 0 here, x of 1, x of 2 and x of 3. All are ones. X of 4, x of 5, x of 6, x of 7, all are zeros. We know the DFT formula. X of k is equal to summation n is equal to 0 to n minus 1 x of n
into e power minus j 2 pi nk by n. K varies between 0 to n minus 1. Now we have to substitute the values for the above equation. X of k is equal to summation n is equal to 0 to n minus 1. Here n is 8, so it is n sub n x of n into e power minus j 2 pi nk by 8, 0 to 7, or summation n is equal to 0 to 7 x of n into e power minus j pi nk by 4. Now we have to expand this equation. X of k, n varies from 0 to 7, x of 0 into e power 0, n value we have to vary, hence it is 1, plus x of 1 into e power minus j pi k by 4, plus x of 2 into e power minus j 2 pi k by 4, plus x of 3 into e power minus j 3 pi k by 4, plus x of 4 into e power minus j 4 pi k by 4, plus x of 5 into e power minus j 5 pi k by 4, plus x of 6 into e power minus j 6 pi k by 4, plus last value is x of 7 e power minus j 7 pi k by 4. Since x of 5, x of 6, x of 7 and x of 4 all are zeros, x of k equation becomes x of k is equal to x of 0 is 1 plus e power minus j pi by 4 plus e power minus j pi k by 2 plus e power minus j 3 pi k by 4, with k varies between 0 to 7. Now we have to expand the value of k from 0 to 7. So if you put the values, one value I will show you, x of 0 is equal to 1 plus e power 0 is 1 plus e power 0 is 1 plus e power 0 is 1, which is equal to 4. Similarly, at k is equal to 1, we get the value k is equal to 1, it is 1 minus j 2.414, x of 2 is 0, x of 3 is 1 minus j 0.414, x of 4 is 0, x of 5 is also 0, x of 6 is 0, x of 7 is 1 plus 2.414j. So final answer we can write x of k is equal to 4, 1 minus j 2.414, 0, 1 minus j 0.414, 0, 0, 0, 1 plus 2.414j. This is the final answer. Next problem. Compute 5-point Dft of x of n is equal to 1, 0, 1, 0, 1 and sketch its magnitude and phase law. It is given x of 0, x of 2, x of 4 are ones, x of 1, x of 3 are zeros with n is equal to 5. We know the formula, Dft formula. X of k is equal to summation n is equal to 0 to n minus 1 x of n e power minus j 2 pi nk by n, with k varies between 0 to n minus 1. So substituting the values, n is equal to 0 to 4 x of n e power minus j 2 pi nk by 5, where k varies between 0 to 4. By expanding the previous equation, we can write x of k is equal to x of 0 e power 0 plus x of 1 e power minus j 2 pi k by 5 plus x of 2 e power minus j 4 pi k by 5 plus x of 3 into e power minus j 6 pi k by 5 plus x of 4 into e power minus j 8 pi k by 5. So by putting the values of k, for x of 0 it is 1 plus 1 plus 1, which is equal to 3. X of 1 is 1 plus 0 plus minus 0.8 minus 0.58j plus 0 plus 0.3 plus 0.95j, which is equal to 0.5 plus 0.37j. So in polar form, we get the answer as 0.62 at an angle of 36.5 degree. Similarly, x of 2 is equal to 1 plus 0 plus 0.3 plus 0.95j plus 0 plus minus 0.8 plus 0.58j, which is equal to 0.5 plus 1.53j, or 1.6 at an angle of 71.9 degrees. Similarly, x of 3 is equal to 1.6 at an angle of minus 71.9. The x of 4 is equal to, we get 0.62 at an angle of minus 36.5 degrees. Now we can plot magnitude and phase spectrum. So this is x of k for magnitude spectrum. At 0, magnitude is 3. At 1, magnitude is 0.62. At 2, magnitude is 1.60, at 3 magnitude is once again 1.60, and at 4 it is 0.62. This is magnitude spectrum. Now we have to plot the phase spectrum. Says x of k, at 0 there is no phase, at 1 it is 36.5, at 2 it is 71.9, at 3 it is minus 71.9, at 4 it is minus 36.5. So this is the magnitude and phase spectrum for the given problem.